Our presentation for this session is SLC TurfTrade, Trade Up, Dry Out, Green Up. And we are going to hear from Stephanie, Jack, and Kelly. Stephanie is a water conservation manager with Salt Lake City Department of Public Utilities. She manages programs that are helping the department achieve its water conservation goals. Jack is the principal at Karlin Consulting, LLC. Since 2014, he has served as the executive director of Turfgrass Water Conservation Alliance located in Corvallis, Oregon. And then Kelly is a professor and extension specialist at Utah State University. She works with federal, state, and local agencies and organizations to improve water use efficiency. So I will turn the time over to all three of them.
Thank you. Eli, can you all hear me okay? Yeah? Okay. If at any point you can't, please just give me a wave and I'll try to speak to the mic. So as Eli said, I'm Kelly Kopp, and I'm a professor at Utah State University. And you know, when we were putting this talk together, I think we realized that this might be a little bit different for this audience. But having just sat in the talk next door and listened to Dr. Mensch and Zach talk about the Great Salt Lake, I feel like we fit very well into the conversations that I'm hearing here today. In particular, when Zach was discussing, how many of you were next door? Okay. Okay. In particular, when he was discussing the Bear River project, I felt this is something that we can relate our work to. And the idea that the Bear River should be diverted to provide water to the Wasatch Front, in his words, to support lawns and gardens, is that how he put it, I think? And so that was the point at which I thought this is some information that I think will be of interest and make it relevant for you all. So we are going to talk today about a program, and it is a program that we've been working with Salt Lake City Department of Public Utilities on for a number of years at this point, to trade higher water use grasses for low water use grasses. And I'm going to talk in more detail about that. We all will. But I wanted to start out by just maybe giving you some context for what it is we're discussing here. So, you know, I often talk about grasses. That's an area of research and work that I've been involved in for 25 years at this point. And I also like to start by describing what exactly it is I'm talking about, because sometimes when I use the term turfgrass, people think I'm talking about, you know, that plastic stuff at Ricecle Stadium, for example. That is not what I'm talking about here. I'm talking about living, growing plant material and a ground cover, and it's a ground cover that can stand traffic over a long period of time, and it has a functional use. So I want to make it very clear from the outset here. This is not about having grass everywhere, and it's certainly not about having grass everywhere we have had it. But in the areas where it still makes sense, in the areas where it still has a function to perform, how can we have it and still do better when we're trying to keep water in the lake, when we're trying to benefit our air quality, and when we're trying to extend our lives in this state, frankly. So I like to start out talking about some of the benefits of grasses, because I suspect all of you, whether it's conscious or not, may have an idea about grasses, what you think they do, what you think they are, how much water you think they need. And that's what I wanted to start out with, talking about some of those things. Grasses are plants. That's something that I think gets lost in the conversation sometimes. And so as plants, they do produce oxygen, and they perform a number of other functions that I'm going to talk about now as well. So one of the main functions that grasses perform is to protect our soils. They keep soils in place. They improve soil structure, air holding capacity. When grasses are grown on soils, it improves their capacity to retain moisture, prevent erosion, and they actually improve soil health over time, which is why some of the world's best soils, highest quality, healthiest soils are in grasslands. That is a fact of science. They also serve very, very well, unlike most plants, to prevent stormwater from running off, and they keep water in place, which allows nutrients to move into the soil profile, to be taken up by plants, and that's why you'll often see them planted in stormwater basins, right? They're performing a very specific function in those places. And a fairly small lawn area can capture thousands upon thousands of gallons of water. So that's another very positive function of these grasses. Something else is oxygen production, and the fact that a 5,000 square foot lawn can produce enough oxygen to support lots of people. This depends somewhat on location, but like any plant, they produce oxygen, and that is then provided to the atmosphere and then to us. Now, this is one that I think is of great importance here for us here in Utah. We know that grasses, and I declined the pointer, but now I'm regretting it a little bit. Hopefully you can see, and maybe I'll just talk you through this a little bit. But the upper left image, the temperature of that water is 94 degrees Fahrenheit. The center left image, that is a grass area that is 104 degrees Fahrenheit. Next to it, sand, 132. Next to that, asphalt, 136. And then next to that, synthetic turf or artificial turf with a temperature of 165. These are all within the same area. Okay? So the point being that the natural grass, which is the center left image, has a temperature that is significantly lower than many other things. Of course, the hardscape, but also the sand, also the artificial turf. And so it's providing a cooling effect in that environment, which in turn is associated with reduced energy costs around structures which we may be cooling. Okay, so there's a real benefit there. And I also just want to mention the last point there, which is heat island that we're seeing increase in many cities across the country. And this is some work that came out of Princeton recently, in which they found that certain cities, in Las Vegas in particular, over the 10-year period between 2004 and 2014 had seen incredible increases in urban heat. And particularly in the case of Las Vegas, that coincided with a period of intensive programming for turfgrass removal in the landscape. And so again, I'm not suggesting that we need grass everywhere, but what I am suggesting is that perhaps a more measured approach in which we consider alternatives that will allow us to maintain the benefits of these plants in the landscape are appropriate. Carbon sequestration. This is something that is of increasing interest to me as a scientist. And I actually have been installing a project in the past couple of years to look at climate resilient landscaping and if, frankly, and how grasses play a role there. We know that grasses sequester carbon exceedingly well. They can be on par with trees depending on how they're managed. So if we're concerned about carbon in the atmosphere and climate change and climate variability, they can be part of the solution. Now at Utah State, where I'm a professor, I work with a number of folks, several here that you see, on different kinds of turfgrass research. And I just bring this up because this is not something I do on my own. This is certainly a team effort, and I'm very appreciative of my collaborators. And we do a lot of different kinds of research. We look at irrigation technologies. That's something I'm very interested in to help us reduce outdoor water use. We look at pest management. We look at different things like irrigating during the daytime versus the nighttime. And if you're interested in that, I'd be happy to chat with you at length. It's not what you think, I suspect. But what I wanted to emphasize here today is the work we do in turfgrass species and variety trialing. Because I suspect many of you are not aware that within the realm of turfgrasses, there are, of course, different species, but there are, within those species, literally hundreds of different varieties. It's kind of like tomatoes. You know, you may know a handful of tomato varieties. Roma, Big Boy, Early Girl, right? Turfgrasses are the same way. And there can literally be hundreds of varieties, and those varieties can have widely ranging requirements for water and other inputs as well. And so that's why we do a lot of this work, trialing different species and varieties to see which one performed best in this area. Now, I'm not going to get into all of these. I'm not going to just list them for you, but this is just to give you some context for how much of this work we do. So we look at different species, as I mentioned. We look at different varieties. We subject some of them to sort of standard maintenance practices, so regular watering, fertilizing, etc. And then actually most of the work we do is subjecting these to drought and seeing how they perform under drought conditions with the goal of having good recommendations for you, right, for the public at large. And so we do this in conjunction with a number of different organizations, in particular the Turfgrass Water Conservation Alliance, with which Jack is the executive director of. But again, the goal of having species and varieties to recommend that are going to be low input, low water use, and still provide us a lot of those ecosystem services that I mentioned in the very beginning. So as I mentioned, we do a lot of work screening these for drought, and the goals are to see how these respond to either acute drought, which means we simply turn the water off entirely, or chronic drought, which means we apply a lower amount of water but consistently through the growing season. Then we're able to identify superior varieties which within the species that we're looking at. We can start to evaluate the mechanisms, the physiological mechanisms by which these species and varieties use less water. And then, and you're going to hear more about this from Jack, those can be branded or, in my case, recommended for use for various purposes and applications. So this is an aerial image of our research farm. And you can see a lot of little tiny squares there. Those little tiny squares represent different varieties of grasses. And they are undergoing different treatments, mostly drought. And as you can see, we've got a lot of different trials going on there, and they're constantly turning over. Many of these trials will last for 3 to 5 years. So we're not just looking at 1 or 2 years, we're really trying to get a sense of how they perform over time under different climate conditions. And that's how we establish them and begin to collect data. This is a study, just so you could get a little bit closer look at one of these. These plots are typically 1 by 1 meter, and they will be replicated. And as I said, we will impose drought on them and see which ones perform best. So this is the point where I'm going to hand it over to Jack, and then at the end, we will all wrap it up together.
Oh, how exciting is that? Thank you, Karlin. Excuse me, you guys will have to pardon me. I have a little frog in my throat because I have kids that cough directly into my face. So bear with me. As Kelly said, her trialing program is central to TWCA's program. Now, Turfgrass Water Conservation Alliance is a 501c3 nonprofit. We evaluate through multi-year, multi-site trialing drought-tolerant turf. Excuse me. We have there's a good list of all of the locations that we have evaluated with. We don't send every trial to every location because that's madness. But we do try and select locations that are going to give us the best national look at a performance of a species. So we do single species evaluation when we do our evaluations. So we are looking at tall fescue or bluegrass, whatever it is, and that way we avoid the karaoke comparison of, well, which grass is better? They all have very unique features that make them suited to very specific applications. So we want people to be able to choose the most drought-tolerant cultivar within the species that best meets their application. So we just want you to have your options. As Kelly said, we do a lot of drought evaluation exclusively for us. When we do this either in field testing, in locations where we know we have, or we can expect an unbroken dry down. In places where we know we're going to get some rain, we use what's called a rain-out shelter. You'll never guess what it does. That's right. It keeps the rain out so we can more tightly control the environmental factors and have that unbroken dry down. As Kelly said, we do either acute stress, which is full water removal. It's here on the right. Or we do chronic stress. Chronic stress we found to be very labor-intensive, and it is very expensive. And what we've seen is that the results are very similar to that of acute stress. So when we do our evaluations, we are bringing it up to uniform green cover and then shutting the water off until the top performing cultivar hits 25% green cover. So that means the most drought tolerant is 25% green. You'll never guess what the least drought tolerant looks like. Actually, you would. That right there is 25% on the right. It looks like dirt. You guys know what dirt looks like. We're all cool with that. This is one of our locations. This is in Penn State, Berks. This is actually the tall fescue trial that we are wrapping up right now. Thank you so much, Kelly, for submitting your data. What a gift. And so we send the same trial out to all those locations so we can say nationally, this is a drought-tolerant turf. This will perform for you. We use digital image analysis to perform this evaluation. This gives us an objective data. Standardization, so we can take the same test and we can measure it the same way across all locations. And that way, we know what we are seeing is in fact a result of that drought tolerance. It eliminates bias. For a long time, we've worked with individual breeders and plant breeders. They're like proud parents. All their plants are their kids, and they don't have any ugly kids. And so by using digital image analysis, we are able to say, look, man, not all your kids are going to go to Mensa, all right? Like they're not all going to be smart. And that's okay. That's okay. That's how life is. When I say it can tell the difference, I mean it can quantify what that difference is. So I can say more drought tolerant. Okay. What is it to what? Here we can make that evaluation using DIA. Here you go. It will tell you exactly how drought tolerant, how much more green cover you get. So it's a real boon for us as we are talking about enforcement and about water use and actual practical levels. The data is taken and evaluated by our data evaluation and statistical analyst, Dr. Tyler Carr at Ohio State University. Sweet guy, super smart, just got engaged. And then it is evaluated by our research review committee, who is a panel of independent researchers who have no financial stake in the outcome of the evaluation. So that way, if it does qualify, that's great. And if it doesn't qualify, that's great. They're going home and eating. There's no reason for them to skew their numbers. And we publish those results. This is something that is relatively new for us, and it is something that I'm very proud of. You can go to the TWCA website, and you can download the qualification report for the drought trial. So if you wanted to look at the Kentucky bluegrass trial that we established in 2018, you can go ahead and download that. You can get that table and see what that drought tolerance is. You will be able to see the difference. Now, I do want to point out that in order to qualify for a TWCA, turf has to perform within 10% of the drought tolerance standards. So that is way, way, way up there. Most of them don't qualify. But what we found is we used to tell our members about what those scores actually were, and then we had a race to the bottom. Because once you get into that drought tolerant, once you say, oh, well, it's drought tolerant, everybody wants to say, well, mine is 0.002% more. There's no statistical difference in that grouping. There's no reason to separate that out. What we found is that is going to create confusion and muddy the water. So it is either drought tolerant or it is not. It is an on-off switch. So that is how we do it. TWCA is very proud of the work that we've been able to do, and we are very proud of the SLC TurfTrade. And with that, I'm actually going to give it to Stephanie, who has most of the stuff to talk about here. So thank you, Stephanie.
Hey everyone, I'm Stephanie Duer. I'm Salt Lake City's Department of Public Utilities Water Conservation Manager. And the first thing I want to say is, okay, so I provided the template for this, and though you see our logo at the bottom, really this USU and TWCA's logo should be on all these slides too, because this program wouldn't have happened without them. So, slide, please, Jack.
Oh, sorry.
Yeah. Okay, so this program just didn't come out of randomness. In 2020, we did our water conservation plan update, And we did a deep analysis of water use by different customer classifications. I won't go into the wonkiness of that. It's something that really only excites people like me. There's like 6 of us. But the idea is we're a large service area. We provide water to a lot of people and a lot of businesses and industries, and we need to know how they're going to use that water, so we know how to help them manage their choices better about how they use that water, so we can make sure those sources are sustained not only now but well into our future. Just as a little FYI, most people think of water use as landscapes and homeowners. Salt Lake City is sort of unique in Utah in that though we have 90,000 connections, we serve about 360,000 people, 14 to 12% of our connections are commercial or industrial or institutional users, yet they represent about 50% of our full water use. Okay. But outdoor water use is still really super important. So one thing we learned in our study was that though we've done a good job reducing water use in our service area over the last 20 years, we still have a ways to go. So what this represents is where we are, well, at least in 2020, in terms of our outdoor water use and our indoor water use. So the indoor water use is down here on the bottom. Outdoor water use is that green bar up on the top, or that green mound. What was important is we've reduced outdoor usage total usage by about 16,700 acre feet, which sounds like a lot, and it is. But what we learned in our last study was that we also have to save an additional 16,700 feet. So we still have to do as much as we've done and more. And what we learned was a lot of this is going to have to come from outdoor water use. And that's because one is we're growing, and about 50% of our water goes to residential or outdoor properties that have landscape. Of the water that goes to those properties, about half of the water they use, especially for our residential customers, goes to the landscape. We also, trying to think of my next slide. The other thing we did is after this is we wanted to understand just because someone is using water doesn't mean they're wasting water. So we worked with Utah State University in another program called Water Maps to do aerial imagery of properties and compare estimates of how much water a landscape needs compared to how much water that landscape is actually receiving. And we know that because we meter you, and I know how you use water, each and every one of you. So what we found out was though 60% of our service area, our residential customers, were using water pretty appropriately. I mean, they're maybe 50% more than they need to water, which sounds like a lot. I still have like 28% of my customers that are using twice as much or more water than what they need. So how do I reach those folks? How do I reach folks who want their lawn? How do I reach folks who, or even commercial properties, HOAs, play areas that want lawn? And it's like, well, what can we do? And I had done the research on heat island effect, and we won't even talk about plastic. We don't have time to talk about plastic grass. So I called my good friend at USU, Kelly Kopp, and said, what grass can I encourage my customers to use? She told me a number of varieties. I started calling companies and said, hey, do you have this seed? And there was one company in particular, present company not included in this, Biograss, not them. I called someone else and said, hey, I want to encourage my customers to buy a certain grass that will save less, save water. And they told me nobody will buy grass seed. So Kelly hooked me up with Jack. Next slide. So to give you an idea of how much water we have to save, as an average, our current landscape choice requires about 29 inches of water a season. I need to get people, and we're applying more than that, about 32 inches. I need to get people below 24 inches, which seems very specific, but it's, again, all measurement and estimation. And so how do we do that? Well, we find a better grass. And if I couldn't find it locally, I was going to find it somewhere. Wave, Jack. So when I was told we couldn't sell seed, Kelly and I, so next slide, I think, and I'm looking at my time, 1 minute. This is what's important, and I think Kelly mentioned this. The Salt Lake City TurfTrade program isn't a product, it's a program. We wanted to educate people. We knew they had to be successful in planting their seed. We need them to be successful. Not just the program success, but our ability to save water is dependent, it's predicated on their success. So we made a bunch of videos about how to do this step by step. We did this at Concord Lift Station first, which is that lovely picture there. By the way, Concord Lift Station, since the installation of our SLC TurfTrade grass, has reduced water use by 50%. And that includes the year of establishment for its low water landscape too. So a bunch of new trees and shrubs, new lawn, still water use down is 50%. So we developed this program, we made all these videos, we got everything ready, and the first grass seed sale went on last summer, and I think we sold out in 14 hours.
No, so the first one, it took us, this is
At first it took us 2 weeks.
Yeah, well,
and then this
one,
news story came
out.
out.
It took us almost 3 months from the time we started.
Yeah, because no one knew about it.
Sold out, because
Until,
nobody knew about it.
and then we had a news story.
Yeah.
And then it sold out in 12 hours.
Yeah.
And then in the fall of last year, we did, and that one went quicker. That was like 36 hours.
Yeah, so we started at almost 3 months. We went to 3 weeks. And then this spring, we did it in
24 hours or less.
42.
42?
Just under 2 days. Yeah.
So we sold, and this last spring we sold twice as much, 3 times as much as we had previously. So basically the numbers are, we've sold 1,674 bags of TurfTrade seed, 5 pounds a bag, or there's 5 pounds, well the new seed is 7 pounds because they coat it so it's easier to plant and does a better job. About 16,000 pounds of grass seed to about 1,000 households, HOAs, a couple of government sites, some city facilities, and we expect to use 30 to 40% less water. And in our last moment, because I see we have the red light, I think that's my last slide. Kelly has, we want her to close us out, and then we'll answer any questions, because that was really fast.
Thank you, Stephanie. So in conversations with Stephanie and Jack about this presentation, I shared that I personally at my home have been going through this transition, trading my turf from a higher water use turf to a low water use turf. And we've actually done some economic analysis of that transition. And at my home, including herbicide to kill the existing lawn, seed, which we purchased, and I'm just going to say it, we purchased ours from Biograss, which is a company represented here in the audience.
Very cool.
Thank you, Biograss. So we purchased the seed, we killed the existing lawn, and we also purchased some compost to insulate that new seed. And in the end, what it's going to cost us is 22 cents a square foot for this transition. And now, granted, I'm a turf scientist, and I also like doing experiments, which my husband doesn't necessarily like on our lawn, but I'm going to do it anyway. I'm fully anticipating reducing our outdoor irrigation by 50% with this transition. So for 22 cents a square foot, with that reduction over time, the return on investment is almost instant as far as I'm concerned. So that was the last thing I want to share. Hopefully we still have a couple minutes for questions. Okay.
Yeah, I think we were good to give you guys a few more minutes, so questions, and I'll bring the mic over.
Is this seed available to anybody in the Salt Lake Valley, or is it only Salt Lake City?
It's initially was available to folks within our service area, but we now have retail providers. So again, I can't say your name, but Hayden, will you stand up and just show folks your lovely sweatshirt?
But can I add too, though?
Yes.
And yes, I'm very appreciative in particular of Biograss, but there is a sod grower in the state now, Chanshare, which is providing sod, and Granite Seed is also another provider. And I guess the point of that is that because of this program with the city, the retail options have expanded enormously. So it is broadly available now.
And I think the other important point too is you don't have to have necessarily this particular blend of grass seed. Any grass seed that is TWCA certified will use 30 to 40% less water than grass seed that is not certified. So the idea here is we can move the marketplace. We don't have to have rock everywhere. We don't have to install plastic everywhere. We don't have to add the heat island effect. We can save water. I mean, ideally, we reduce our lawn footprint at the same time, improve our irrigation systems, change out heads to smarter heads. Not our heads, but, well, yeah, we have to change our heads to smarter heads too, and better spray nozzles at the same time. But yes, so you can get it locally. Just read this man's sweatshirt. And hopefully next spring we'll have more.
My question was just, you guys have gotten down to the seed and how awesome that is. As a user, I switched over, got a ratio for my house and everything. The problem is I don't know how much water to put on my lawn. And I've gone to slow the flow a couple of times, and
Yeah.
you get an idea, but
Yeah.
it's kind of vague. And
Excellent.
you mentioned the night versus day thing.
Yeah, oh yeah, excellent question. So my best recommendation to get recommendations for this low water use grass right now is to go to the state's Division of Water Resources
get
Lawn
ours.
Watering Guide. We worked with them through this process. They have always provided a lawn watering guide for traditional varieties, but they now provide it for the lower water use varieties as well. So I would encourage you to pay attention to their social media. It's there. It's also on their website. The day versus night, I'm happy to chat with you after this.
And we have
Long conversation.
And we have information about how to water both for establishment and once it's established in these wonderful educational videos, which are less than 2 minutes each.
We just moved into our house. How do we know what kind of grass we have?
Ooh, where do you live?
We live in Sugar House.
Okay, so for anybody, it doesn't actually matter too much. Anybody in the state, every single county in the state has a USU extension office that can help you with that, answer that question. If I had to guess though, you've got some mixture of Kentucky bluegrass varieties. Odds are, I can say that with 99% certainty. Yeah.
All right.
She's the scientist, she would know.
Thank you all so much. It was a great
Thank you.
presentation.
Thank you, everybody.